Right, students? Today question it's from hydrodynamics. So hydrodynamics questions actually are not that difficult because we have only two equations. A1 V1 equals A2 V2 and the Bernoulli's equation. So you might think, okay, this question is not that difficult. But in our MCQ paper, we'll be getting this question. We have to do certain amount of calculations. So if you are not familiar with this type of calculations, it will take time. And sometimes you may not be able to do the questions as well. So we need to practice these type of questions. So here I have given one question. So let's practice these type of questions, and if you can do this question, that means you know it. So if you don't know how to do these type of questions, that means you need to practice. So this will be a good reminder to you, practice this type of questions. So let's try this question, try your best. Actually, when doing this question, actually you need to know certain amount of data before doing the question. I mean, in this question we have to use the velocity that flows out of the vessel. So the height is given, so you should know the velocity that flows out of it, the value of it. I'm not telling the value here now. So if you know that value easily, you can easily apply that into the equation and you can easily get the answer. If you don't know, that means you have to do a certain amount of calculation and get the answer. So if you just know it, you can start the question from the middle. That's a small trick actually you should practice. So let's do the question.
Alright, let's read the question first. A vessel of cross-sectional area A kept on a smooth horizontal table. A liquid of density rho is filled up to height capital H of the vessel. There are two holes A and B of cross-sectional area simple A. If the distance between the holes are simple h, find the initial acceleration of the vessel. Right. I hope you have tried the question. So let's get into the question now. Right. So they are telling us a liquid flow will go out from the vessel, and because of that the vessel will have an acceleration towards left or towards right. Right. So first thing we need to know, actually we need to find the velocity change or the velocity of flow that goes out of the vessel here. The point here is this. Say now the vessel, there's a liquid flow in this way and there's a liquid flow in this way. What actually happens is there's a change in momentum. If the velocity, if the momentum here, the momentum change in the liquid is m1 v1, that flows out is here m1 v1. If the velocity that, if the flow that flows out is here m2 v2, so what actually happens is when there's a momentum change two different directions, m2 v2 minus m1 v1, and divide by total mass, we get an acceleration. That's the reason for this acceleration, the motion of this vessel. Right. So to find the acceleration, now you can see we need to find the momentum change. You need to find the velocity here, VA velocity and VB velocity both. Right. Finding VA velocity and VB velocity is the real question here now. Again, I am telling you, if you want to do this question very quickly, you should know the velocity that flows out this vessel. In a normal question, if you have done questions like this, if the liquid height is simple h, the liquid that flows out from the bottom is root 2gh. Actually this equation we can prove from Bernoulli's equation. So I am not going to prove it here, I am just using this equation right here. So the liquid flow that flows out is root 2gh, h is the height from the above. Right. Now to find the velocity that flows out here and point B as well, we need to find the height, this height and of course this height. So finding these two heights is crucial. Actually to find these two heights, I need a support. So actually this height, the height for the bottom hole, actually that is not given. So I'm going to assume that is as x. Right. So by using this value I can find the heights. So if this is x, the height here, the total height will be simple h plus x. So the depth here will be capital H minus simple h plus x. And for this particular hole, the total height that will, and the height for this point B is capital H minus simple x. So now we have the both heights, so we can find the velocity, of course, right. Now let's take the velocities like this. This is our vessel, point A, point B, right. Let's make it a bit of clear, right. Let's draw it again then. Alright, this is a vessel and point B, point A. Now we know the height, this is h minus x, and for here is h minus h plus x. So the velocity that goes out from A is root 2g capital H minus h plus x, and the velocity goes out from point B is root 2g capital H minus x, right. Now we have the velocities. Now we need to find the mass per unit time. We need the mass per unit time, right. Alright, finding mass per unit time, of course, mass is actually, the flow goes like this, cross section area is, so cross section area into V, volume flow rate, cross section area into V into density, that is mass, and that multiplied by velocity, we get mv value, right. So simple A, velocity is this, root, just look at it very carefully, 2g h minus h plus x into rho. Again we need to multiply it, velocity root, so you can see root 2g h minus this h plus x value will cancel off. So we can easily simplify it like this. So if I am moving into, so it's A, this root value will be removed, then 2g h minus h plus x into rho. So this is the value for, yes, from A, momentum from point A. Again from the point B we can apply the very same equation, you don't need to write everything, it's just let's apply the very same values, right. A is same, 2g, of course, the velocity we can write it like this, h minus x into rho. So these are the two momentums, mv and mv, right. We are almost getting closer to the answer now, right. Now we have both momentums, we have this direction momentum and the other direction momentum as well, right. So this is our point, we find the momentum change and we divide it by total mass, we get the acceleration. So momentum from this and this point, you can see the point A and point B, actually point B momentum is higher because it's bit lower, so the velocity is higher, the momentum is higher. So what we have to do is we have to subtract B by B minus A actually. So let's write it down, 2g h minus x rho minus A 2g, here also we need A 2g h minus h plus x rho, right. Let's simplify it now. Hope you can see this A, let's take the values that are common out, so A, 2g and rho is common, right. Then we have h minus x minus capital H minus simple h, actually it's plus simple h minus minus, and then finally plus x, right. Now you should see the values that cancels off, right. So these are the values, capital H cancel off, and the simple x cancel off. We are getting only a 2g rho simple h. So this is the momentum change per second, and that is divided by total mass. So total mass we can find, because the cross sectional area is capital A, height capital H, so A into height we get the total volume, and that multiplied by density of the liquid. Again you can see that also cancel off this rho and this rho. So the final answer will be 2g h A over capital A h. This is